Hello, welcome to Introduction to Databases and SQL. In this session, we are going to discuss about MySQL constraints, namely not null, unique, default, primary key, foreign key, and check constraints. Let's begin. MySQL constraints. So in MySQL, which is a relational database management system, we can actually enforce some constraints. That means we can impose certain rules. And all these constraints are defined already in SQL. MySQL is SQL compliant database management system. And all these constraints available in all other relational database management systems as well. So we can say either SQL constraints or MySQL constraints. And these constraints are also called as integrity constraints. Why we call them as integrity constraints? Because these constraints help us to maintain the integrity of the table. What is integrity of the table? Means whatever the data that is stored in the table or a database must be valid and correct. So we can say to maintain the integrity of the table or a database, because in database only you will have all the tables. So you enter some data as part of the fields or the columns, and you have to ensure that the data that you have entered is valid and correct. So for example, India is a country and capital is New Delhi. Wherever India comes, its capital should be New Delhi. It shouldn't be any other city actually. This is called integrity. Other example, you have an employee table, let us assume. So each employee designation, there will be some basic pay. Okay. So employee X designation will have some Y basic pay. Whenever X comes, Y should be the basic pay. It should not differ actually. So if it is differing, then that is a violation of the constraint, or we can say that's a violation of integrity. So the data is not valid or not accurate, right? So in order to achieve this, we will have the integrity constraints. Okay, and of course, there are several integrity constraints which help in different means. So by using these SQL constraints, we specify the rules for data in a table. So what data should go into the table? Okay, so what data will be automatically placed if some column data is not given? Whether the data should be duplicated or it should remain unique. So all these things we will actually mention with the help of these SQL constraints. Right? So we will specify rules for the data in a table such that we achieve the integrity of the database. If there is any violation, then the action is aborted. So for example, the country name, as I told, is India and the capital city is New Delhi. Later on, when somebody inserting the data, India comes again and the capital name is something else, then it will check. And that action will get aborted. Okay, and of course, we have a referential integrity also that is more useful when you have multiple tables and you are actually relating one table to the other. So that will be specified with the foreign key that we are going to discuss. And coming to these constraints, and these constraints can be either column level or table level. When you are specifying the rules, you can specify that rule for a column level or table level. For example, one column field, I want the default value as 0. I want the default value as null. I want the default value as some other data item. You can actually do that. So an example, default is a column level constraint. And primary key. So primary key, foreign key can be at table level constraints. So constraint can be either column level or table level. Column level constraints apply only to that column, and table level constraints apply the whole table actually. Okay, so we will discuss each of these constraints explicitly by creating tables and by working with the data in it. And now, so we have the 6 constraints which are defined as part of the SQL. So one is the not null constraint, and this not null constraint ensures that the column cannot have a null value. It's a column level constraint. Whenever you say not null, that column cannot have a null value. So you must have to provide a value to that. So that is the not null constraint. So as you know, SQL is case insensitive, right? So you can actually give not null in smaller or capital or whatever the means. So not null means the column must and should have a value. It cannot be null. That is easy to understand. And then unique constraints. By saying unique, you are saying it should be unique. So that means there is no duplicate. Unique ensures that all values in a column are different. So for example, I have a list of countries in my table. I have my country table and I should have all the country names. My country name should be unique because this is a list of countries, right? So country name should not come again and again. So now I can say unique. You have inserted India already and later you want to insert again India, then this unique constraint will fail because it ensures the column values are different. There are no duplicates. You want to avoid duplicates, you can actually go with the unique. Not just one column, you can actually make multiple columns as unique also. So unique can be given as a table level as well, because that's not just for one column. It will be for combining multiple columns. So that we will see as an example. Okay, so unique ensures that all values or column values are unique. There are no duplicates. And coming to the third, which is very, very important, that is primary key. So primary key constraint. Every table in relational database management system should have a primary key. So that's the recommendation. So of course we have written tables without any primary key, but the recommendation is every table in any relational database should have a primary key defined. And there should be only one primary key. A primary key should be defined and it should be only one primary key. What is the purpose of the primary key? The primary key uniquely identifies each row in a table. By using that key, we can uniquely identify a particular record or a row in that particular table. Usually your IDs, customer ID, student ID, employee ID, because they are unique and you have to provide the value for it. And by using that particular ID, you can get entire row record of that particular employee or entire record of that particular student. So for that purpose, we need to mention a primary key. And primary key is a combination of not null and unique. That means primary key value cannot be duplicated. It should be unique. That's why it uniquely identifies each row. And it is not null also. You should not make it null. A primary key value cannot be null. So by default, when you say primary key, automatically that field is going to be not null and that is going to be unique. At the same time, primary key cannot be a single column. It can be actually the combination of multiple columns, just like unique. So primary key is a table level constraint. It can be a single column or it can be multiple columns. Yeah, then come to the foreign key. So in order to explain the foreign key, we need to have two tables. Foreign key concept comes when you have at least two tables and these two tables are related. So that's why we call a child and parent tables. So you should have one child table, another table is a parent table. What foreign key will do is to ensure referential integrity of the data. Referential integrity of the data. Okay, let me explain this foreign key with an example over here. So let go over here. Now I have a table customer. This is my customer table. And here I have three fields. I have CID, CNAME, and city. And here CID is the primary key. By using CID, we can identify each customer, right? So now let's say 1, 2, 3, whatever the data. So let's say some ABC, and city is, let's say, Pune. Okay, so now I have 3, 2, 1, and I also have XYZ here. And the city is going to be, let's say, Hyderabad. So here CID is the primary key. It should be unique and it should be like that. I have data. Now I can actually have another table called orders. So where order ID is there. So 1, 2, 3, 4, 5 is the order ID. Order amount is actually some 5, 4, 3, 6, 7. And order date actually. So the date format in MySQL is actually YYY hyphen MM hyphen TDH. So for example, the order date is, let's say, 2023 and the month is 01. The order date is, let's say, 15. Okay, and there is a customer ID also. So who is ordering this order means customer. So this customer is actually the customer from this particular customer table. Whenever he is a valid customer, then only he can order. Right? So now I can specify 1, 2, 3. So 1, 2, 3 has ordered on this particular date with this much order amount. Okay, so now I can have another order ID with some another amount and with another order date. Okay, so this is 01, and after 5 days, the same customer has ordered another thing actually. Right? In the same fashion, I can actually have some order ID. So that is this much, and order amount is, let's say, 10,000. And this is ordered on 2023, so 01, and let's say on 21. So this is the date format in MySQL. We will discuss that. And the customer ID is 321. Okay, so here we will actually enforce the foreign key constraint here. So in this particular table, this order ID is a primary key, and this customer ID references customer of CID. That means it references CID, which is from this particular table. Right now, there is a referential integrity. So what we are saying here is, while creating the orders table itself, I am telling I have the customer ID, which is a foreign key. So this is actually a foreign key, which references CID of customer table. That means whenever you have this particular value, this should be already available in this customer table. So as an example, in the real world, I will tell you, you want to order some products from Amazon. So in order to order, first of all, you should register, right? So when you register, then only you will have all this data available over there in the table. Then you will be asked to order actually. Right. So if it's a valid customer, then only the order will be given to that particular customer. Right. So if there is no customer and you are trying to insert an order over here. So let's say the order is going to be like this: 1, 2, 3, 4, 6, and order amount is some 15,000, and you are ordering on some date. Now I will let you say you are ordering on this date, let's say. Okay, so now your customer ID is actually like 444. Now what happens here? The action is aborted. The action is aborted. So it's not possible because the customer ID, which references to the customer table over here, and this customer ID doesn't exist. So this is a referential integrity constraint violation. So this is not possible. So in this way, we can actually ensure integrity among multiple tables by using this foreign key constraint. Not only just at the insertion time. So if somebody want to delete from orders, so if you delete this particular order, okay, so what should happen actually in the parent table? And for example, if you want to delete from the parent table here, want to delete this particular row, what happens with this customer ID? So these are all the things that we have to discuss when we are discussing thoroughly on foreign keys. So the foreign key is an important concept. Based on the same, we will have joins created among the tables, and we will actually extract the intelligence of the knowledge from multiple tables. So this is a brief of the foreign key constraint, and we'll come back onto this later on. Yeah, so the fourth constraint is a foreign key, and it is used to ensure referential integrity of the data. So you will have both table child and parent tables. The child table, you have the foreign key, and in the parent table, you will have the key and which is being referred from the child table. So foreign key is a key that should be a primary key in other table and referred from the child table. So whenever you are referring to a key here as a foreign key, it should be a primary key in other table. It must be a primary key. So that we have to understand. So then coming to the check constraint. So check constraint ensures that the values in the column satisfy specific condition. So for example, I want to, when I'm creating a table actually, customer table, and legally any customer should be of age greater than or equal to 18. So for example, like in the customer registration, somebody giving the age as 15 or age as 10 or 9. So he cannot be considered as a customer, right? So that constraint I can specify using check. So I will say actually. So when creating customer table, then I will say age int check age greater than or equal to 18. When the age is greater than or equal to 18, then only that is allowed, the data item is allowed into your table. Otherwise, it's simply the action will get aborted, mentioning the constraint violation. So like these check constraints can be verified. So whenever you are entering cities, you can actually check whether that particular city is allowed or not. And whenever you are from different country, so you can check, you can make a check constraint whether that country is allowed or not, or what are the countries which are allowed. So all those things we can actually specify so that our data will be valid. Okay, so that we actually do with a check constraint. And coming to the one more important constraint, that is the default constraints. So default constraints sets a default value for the column if no value is specified. It's a column level constraint. So whenever you are saying country, let's say it's country, a varchar of some 20, default, and you can give the country, default country. If the country name is not given, so what is the default country? That we can actually specify. And whenever giving age, if age is not given, what is the default value? Or if something is given, so something is not given, whether it should be null, you can actually say default null. The default value is null value. A default value is an empty string. Default value can be a 0. Or default value can be anything based on the requirement. Right, so these are about the MySQL constraints or the SQL constraints, and they are very useful. And without this, you can't actually find a table in real time. So at least there should be a primary key, because every table should have a primary key. Now coming to the syntax, you can specify this constraint at the column level. At the column level, you can actually specify if they are actually taking only one field. And you can actually specify at the table level also. So constraint can follow a column, otherwise it can follow the whole table here. For example, column 1 data type, and here I can say primary key. Okay, and the same thing I can actually specify over here also. So primary key I can write here. I will remove there and I can write primary key over here. The table level we can specify and the column level we can specify. If they are column level constraints, then specify at the column level only. For example, default value, you can give the default value here itself. You want to say not null, you can say not null here itself. So if it's a primary key, that's a table level, right? So you can actually specify here if it contains multiple values. Otherwise, you can actually specify as a column level also if it is a single value. Okay, so the point here is you can specify a constraint at the column level if it's a column level constraint. And if it's a table level, if it is a single, it's on single column, you can specify at the column level, or you can specify at the table level as well. So primary key can be specified at the column level and table level also. Check can be specified at the column level and table level also. And unique can be specified at the column level and table level also. And foreign key usually we specify at the table level only because it has to reference to the primary key of the other table. Okay, so this is the theory about the MySQL constraints. Let's go and see some examples. Let me open MySQL here. So let me increase the font a bit. Yeah, so let me check which DB I'm using now. So how to check what DB I'm using? Select database. So I'm using MyDB. Okay, so now let's see the tables in that particular DB. Show tables. Show tables. So these are the tables actually. I have EMP and employee table. Only two tables are there. Right? Let me actually see the structure of the employee table. See here, I have here employee 5 fields, columns, and everything is null actually. Everything is null. So I have not specified any constraint. And there are no keys, no foreign keys, and no for primary keys. And default value is null because I haven't specified anything. So default, it is taking as null only. So let me actually show you how this table is going to get created. Show create table EMP. Then you will understand about those constraints actually. Okay, now you can see create table EMP. Employee ID int default null. Actually, I have not specified when I'm writing. When I'm creating a table, I have not specified default null. So if you are not specifying anything, the default value for that column is going to be null. So that's why for each and every column, I have the default equal to null because I haven't specified any constraints, not null or default value, something else, or primary key. I have not specified anything. A simple, a plain table we have created just with column names and data types. That's why every column default value is taken as null actually. That's why you can see here, everything is null. And the default value is null. By default, you are not giving anything. Then the default value is going to be null. So that means you are not entering data into your table. All the column values are going to be null. Okay. So now what I do is, since I haven't specified any keys or default values, etc., this table of not help to understand the MySQL constraints. So that's why what I do, I will actually change my DB to old DB. Right? So for example, I want to show you the databases over here. Show databases. Here, this is our DB which we are working in, that is MyDB. And we have the old DB also. Right? And by default, MySQL provide you that old DB while you are installing. Let's have that old DB. That's more useful actually. So now let's actually use this old DB. Yeah, so database change to old. And now you can actually show tables. And when you show table, it will give you 3 tables actually. So one is city, another is country, another is country language. So now let me actually tell you how this country table has got created. Okay, so now I will show you. Show create table country. Now you can actually see so many constraint which are specified, at least primary key will be there. So create table country. Now you can actually see how this country table has got created. This is important to understand. Let's go through. So create table country, and we have a code which we are saying not null, which we are saying not null. So not null constraint came up, and we are also saying default. The country name is not given. So default is an empty string. The country name is not given. What we are saying, the default value is going to be an empty string. And then name, again not null, and default is going to be empty string. However, the continent. So continent, if you can actually see here, it is not null, and default value is Asia. We're saying continent. Okay. And what is the type of the continent? The type of the continent is enum. Okay, so here you can see the type of char or char 3, char 52. We can actually have varchar as well. And here, this particular continent type is enum. We have enum types also. Enum means enumeration. So we will have some symbolic constants like directions, month names, day names, like continents, because they are fixed, right? So symbolic constants, any are there. So those we can actually take as the enum. So we have fixed continents, right? They are never going to change. Now days in a week, months in a year, directions. So all these things we can actually take up as enum. So continent data type is enum, and the constant is not null, and the default value is Asia. So if you are not giving a value, then it's going to be Asia. And then region, not null, and default is actually space. That means empty string. Its default is not null actually. It's not null. Default value is not null value. It's an empty string. So there is a difference between null, empty string, and 0. And surface area, not null, and default value is 0.00. Independence here, we are just saying default can be null. So if you don't know, if you don't give value, that is going to be null actually. So here default value is null. And population, not null, and default value is 0. So here almost everything we are saying not null only. That means up to population, everything is not null. So you have to provide the value. Life expectancy, the data type is decimal, just like float. Total 3 values will be there. Total 3 values will be there in your decimal. So that means 3, 1. And default value equal to null. So if you don't know, it can be null actually. And GNP, you see life expectancy, GNP, and GNP old, right? So these things are not null. That means if you are not giving, the default value is going to be null for them, right? And the local name, it should be not null. So you must have to give the local name. If you don't know, the default value is going to be empty string. Government form. Okay, so here it is not null. Again, default is empty string. Head of the state, you can omit this. So when you omit, the default value is going to be null. And the capital, and if you don't know the capital, it can be left null actually. And code 2. So code 2 not null. So code 2 is actually refers to the city of that particular country. So not null and must be specified. Not null means if you are not giving the value, then it's going to be not null, but it's going to be an empty string. Now if you see here, there is a primary key. So what is a primary key? Code, country code. So country codes are primary keys. So when you say primary key, automatically it is not null, of course, and it will become unique as well. Okay, so that's about the country table. So let's understand the city table also. First, let me actually describe the city. See here in the city table, you have all not null values only. Null, so everything is no. All are not null only. And here the ID, the city ID is going to be the primary key. City ID is going to be the primary key. And of course, extra auto increment is also there. I will explain what is auto increment in the next class. So IDs will get automatically incremented from 1 onward. Okay. So then here we have name, country code, and if this is the country code is MUL actually. So key is MUL means it's a foreign key. It's a foreign key. Key is MUL means it's a foreign key. Okay, so let's see how we are going to create this table. How we have created this table. Show create table city. Now, if you can see here, the city table was created like this. ID int not null auto increment. So we can actually specify this extra thing to the ID, so automatically get incremented. Name is not null default, country code is not null default, empty string, and the same thing, everything is not null. But here you can see primary key is ID. So we have specified this primary key as a table level, and you can actually see there is a key country code, and which is actually a foreign key. Foreign key, constraint foreign key references code of the country table. So in the city table, we are actually mentioning foreign key, which refers to the code of the country. So country is a parent table and city is the child table. The same is actually the case with the show create table country language. We have another table that is country language in the world DB. Now here also we can see foreign key country code references code of country. And this table has a primary key, which is actually the combination. If you observe here, the primary key is not just one value, not just country code, it's country code plus language is the primary key. So your primary key can be multiple keys. And here you are having a foreign key that is country code, which is referring to the code of the country actually, right? So this is how in real-time databases, you will have the constraint specified. So hope you have understood a bit of MySQL constraints theoretically, and in the next class we are going to discuss each of these constraints in a practical manner. Hope you have understood, and see you in the next session.